There. My name is Dr. Jill Buckley, and it is a pleasure to welcome you to this special summer edition of Research Methods and Statistics 1. So, in this particular video, what I'm going to do is I'm going to go over the first problem or the first question on your Module 2 homework assignment. Okay? So, hopefully, most of you found the material in Module 1 and Module 2 to at least be somewhat familiar, right? Even if you've only taken Psych 101 at this point. But it quickly can become sort of complicated. And obviously, we're not meeting, one-on-one or in person. So I wanted to go over the first problem of the homework with you just to make sure we're all on the same page. Okay? Okay, so what I'm going to show you right now is, as you can see, we have the following problem in homework 2, right? So this is question number 1. So question number 1 says, a market researcher was asked to evaluate 3 different models of skis, Model A, Model B, and Model C, in order to determine which model was fastest and should thus be marketed. She hired 30 expert skiers to test the skis. Each skier was fitted with a pair of skis of each model type. To control for the possible effects of some extraneous variables, right, the boots and other clothing worn by the skiers was held constant. Similarly, to control for order effects, all skiers used the 3 models in the same sequence. First Model A, then Model B, finally Model C. To avoid fatigue effects on run times, she had all skiers make the first run at 9 a.m., the next at 11 a.m., and the last at 1 p.m. After analyzing the data, she found that run times were significantly faster for Model A, which took approximately 4 minutes and 47 seconds. Then for Model B, which took approximately 5 minutes and 18 seconds. And finally, Model C, which took 5 minutes and 33 seconds, right? So she concluded that since Model A was fastest, she advised the manufacturer to market Model A, okay? So there's a lot going on. There's a lot going on in this example. But let's go ahead and take a look at the questions that you'll be asked to answer, right? So question number 1 for this first prompt is to identify the type of research described. So in module 2, we talked about 3 different types of research methodologies. We talked about experiments, quasi-experiments, and correlational studies, okay? So you might notice in the description of the study that there are certain words, right? Certain words that should be familiar to you from when you completed your lab assignment, right? So the first thing to notice, the first word, right, that should have jumped out at you is the word control. So to control for the possible effects, right? The next word that should have or phrase that should have jumped out at you is extraneous variables. Okay? And again, we see that word in the next paragraph, control, right? So all of these buzzwords, if you're paying attention closely enough, should have indicated to you that this particular type of research is experimental. But if that didn't jump out at you, that's totally fine. Let's talk now about why this is experimental as opposed to quasi-experimental or correlational. Well, first we need a definition, right? Or we need more information. So let's just review. What is a researcher's goal with an experiment, right? The researcher's goal is to establish cause and effect, okay? And the way that we do that is by manipulating an independent variable or IV and observing the effect on a dependent variable, right? So that's a lot of words, okay? So I'm going to try to simplify it even just a little bit easier by saying that experiments most principally make group comparisons, right? And those comparisons are, in effect, the levels of the IV. And to make these comparisons, researchers who conduct experiments utilize something known as random assignment. Random assignment. Okay. So, let's move on to the second question, okay? And then we'll come back. We'll come back to this idea of the fact that this is an experiment, right? So let's really quickly read question number 2. Oops. Question number 2. So question number 2 and question number 3 state that you should identify the independent or predictor variable as appropriate. And question number 3 says, identify the levels of the independent variable. And question number 4 says, identify the dependent or criterion variables. Okay? So the first thing to note with this, right, is that we talk about independent and dependent variables only in the context of experiments and quasi-experiments. When we talk about predictor and criterion variables, we only do that for correlations, right? So already we know we have an experiment, which means we have an independent variable with X number of levels and a dependent variable, okay? So the variable that the researcher is manipulating, okay, or another way of saying that are the groups that we are comparing, right, our ski models, right? So our independent variable is models of ski, or models of skis, and our levels, okay, are model A, model B, and model C, okay? And you don't have to worry about this yet, but just for your knowledge, okay, because everybody tried model A, everybody tried model B, and everybody tried model C, when we compare the run times, we're comparing each participant to itself, right? So we're comparing how fast participant number 11 performed with model A to how she performed with model B and model C, right? So when our comparisons are within the same subject, we call that within subject. Okay, so the alternative to that would be between subject, where some people try out model A, some people try out model B, and some people try out model C. Okay? Okay, so we already have number 1, it's experimental. Number 2, the IV is models of ski. And number 3, we have the levels of the independent variable, right? So now we still need to talk about the dependent variable, right? So the dependent variable is run times, okay? But we want to be as specific as possible, right? So we want to provide operational definitions. So in interest of specificity, we're going to include the units, okay? So the units are the units of measurement, right? So for example, we could say run times in minutes. And if we wanted to be even more specific, we could say run time and operationalize that as the time it took participants to ski from point X to point Y in minutes, right? So as much specificity as we can. That's what we're looking for with operational definitions, again, for the purpose of replication. Okay. So before we get to the last question, right? So we've actually gone through number 1, number 2, number 3, and number 4. So we've identified that this is an experiment. We've identified our independent variable. We've identified the levels of our independent variable. And we've identified the dependent variable, okay? So just like that, we've gone through the first 4 items, okay? But let's return to our original question, right? So the original question I proposed when I answered number 1 is, why is this an experiment versus a quasi-experiment, right? Or an experiment versus a correlation, okay? Well, with quasi-experiments, right? With quasi-experiments, we are not able to randomly assign. Right? So in this case, random assignment didn't matter as much, didn't matter as much because everybody utilized Model A, Model B, and Model C, right? But say that if we wanted to make the model of C a between subjects variable, right? We could have randomly assigned people to A, B, or C instead of A, B, and C, right? So random assignment means that everybody enrolled in your study, right? So in this case, all 30 of those expert skiers have an equal chance of being placed into all three of your levels, right? So if we were to randomly assign participants to either model A, B, or C, random assignment would be achieved by, for instance, putting all of your participants' names in a hat, right? And randomly um, selecting them for model A, model B, or model C, right? But and so that would be very easy to do, right? So with this particular study, we are able to randomly assign if we wanted to, right? But there are other variables that it's not possible to randomly assign, right? So, what if we wanted to look at the effects of smoking on skiing efficacy, right? So, we wanted to take, I don't know, former Olympic skiers that have recently taken up smoking, right? To see how fast they could use each of these skis, right? So, obviously, we can't randomly assign some people to the smoking condition and some people to the not smoking condition, right? Similarly, we can't randomly assign someone to be a Republican or a Democrat, right? Political affiliation is individualistic, right? It reflects an individual's person's beliefs about the world, right? We can't experimentally manipulate that. Just like we can't experimentally manipulate gender or biological sex or trauma exposure versus no trauma exposure, right? So when random assignment is not possible, right? When we're not able to randomly assign, that is a quasi experiment. So it's not just right? Um, that the researchers didn't randomly assign, right? It's not just the absence of random assignment, it is the inability to randomly assign, right? So, because it is possible to randomly assign people into different types of models of skis, and because we are making these group comparisons between A, B, and C, okay, we have experimental, right, as opposed to quasi experimental. Now let's talk about why this is experimental and not correlational, right? So, again, our goal with this particular study is to establish cause and effect, right? And so, what enables us to do that is the manipulation of an independent variable and the measurement of a dependent variable, right? So, we're manipulating the independent variable and observing the consequences of that manipulation on the dependent variable, right? So, in essence, experimental and quasi experimental studies all make these group comparisons, right? We're comparing model A to model B to model C on runtime, and we're observing the effect of model on runtime. Or we are comparing the efficacy of three different antidepressants, Prozac, Cymbalta, and Zoloft, right? And we're observing the effect on rate of depression as measured by the Beck Depression Inventory, right? Correlations, in contrast, don't make group comparisons. They simply observe, okay? The key word there is observe a given variable without manipulating it, right? So how might we change this study to make it correlational, right? Well, let's suppose, right, that we wanted to look at the effects of, let's see, or if we wanted to look at the relationship between ski run times and the amount of exercise the skiers got, let's say, daily, right? So notice we're not manipulating anything, right? We are simply counting the number of hours of daily exercise each of our participant gets. And we're also, with our stopwatch, right, measuring how long it takes our participants to get from point X to point Y, right? Or to make that particular ski run, right? So, in essence, correlational designs are a lot simpler because we don't have random assignment. We're not making group comparisons. We're just taking two different variables that we might think could be related and comparing them, right? Or observing them and seeing if there's a statistical relationship, right? And it could be anything. It could be one of our variables could be height, and another one of our variables could be shoe size, right? Again, we're not manipulating anything. So we're not looking at people with small feet versus big feet or tall people versus short people. We're just quite literally measuring height in inches and um, um, shoe size, right? Um, so that's another example of correlation, right? So correlation, unlike experimental and quasi-experimental, is just looking at the potential relationship between two variables, and we're not manipulating the variables, but rather we are just observing them and trying to see if there's a relationship between them, a statistical relationship. Okay. Perfect. Okay. So the very last question, number 5, is to point out any serious problems with the design of the study or the conclusions drawn and suggest ways to correct these problems. Okay. So let me do some erasing real quick. So one of the things that we have discussed, right? When I was introducing these different types of research methodologies, is we've talked about the different limitations associated with each, right? So, for example, when we talked about correlational studies, the main principle or the main limitation of correlational studies is that correlation does not imply causation, right? So just because two variables are related to each other, right? Or just because we have a statistically significant positive or negative correlation, that doesn't necessarily mean, right, that variable A causes variable B, right? So we talked about, for instance, the third variable problem. But when it comes to experiments, okay, the problems that we have to be aware of, right, are twofold. So with experiments, we are concerned about extraneous variables and confounding variables. So what is an extraneous variable? An extraneous variable is a variable that affects all levels of the independent variable the same way, i.e., the same direction. Okay? Or another way of thinking about it is with extraneous variables, they impact the dependent variable in the same way across all levels of the dependent variable, of the independent variable. I'm sorry. So extraneous variables impact the dependent variable in the same way, regardless of the particular level of the independent variable. Okay, so that's a lot of words. Okay, so what do I mean? Well, let's suppose that I am looking at model of ski, right? So that is our basic manipulation as model of ski, right? But it turns out that the particular day that I choose to have all of my skiers go out and ski, there is a terrible, terrible ice storm, right? So there's a terrible ice storm with like basketball sized hail, and it just, uh, you know, just impales all of these skiers. Okay, they're literally being plummeted with thousands and thousands of basketball sized hail, like ice balls, right? So what the effect that we would expect, right, is regardless of whether you're using model A, model B, or model C, right? Your run times, or I should say, your run times, right, are going to go up. Okay. So your run times are going to go up or be increased. It's going to take you a very long time to safely sort of get down that hill, right? Or another way you could look at it is maybe it takes you less time because you're just kind of falling down the hill, right? Either way, we wouldn't expect any differences between Model A, Model B, and Model C, because no matter what type of skis you have on, right, being plummeted with basketball size hail is going to adversely affect your ski performance, right? And I'll again use the previous example, right? So the previous example of students being randomly assigned to either an open book or a closed book test, right? So ordinarily, without any other variables present, we would expect students in the open book test to do better than the closed book test, right? But let's suppose while the kids are taking their tests, suddenly a marching band, right, starts walking past the school building, right? In that case, again, I would expect performance to worsen, right, for both the open book and the closed book students, right? So an extraneous variable is going to impact the dependent variable similarly across all levels, right? And that's going to be a problem, right? Because it doesn't allow us to appropriately get apprised of what the effect of the IV is on the DV, right? So that's an extraneous variable, right? Okay. So now let's talk about the other potential problem for experimental designs, right? And this is something known as a confounding variable. A confounding variable, right? So a confounding variable a confounding variable, okay, for all intents and purposes is an extra independent variable that is unintentional. Okay. So a confounding variable is something, or I should say, an additional variable that differs systematically along with the independent variable, right? So a confounding variable is an extra independent variable that is unintentional. And another way of saying it is it's an additional variable that differs systematically along with the IV. Right? And extraneous variables are a problem for experiments, right? Because the goal of an experiment is to establish causality. And in order to do this, the researcher must be sure that the IV and only the IV is causing change in the DV. Okay. So taking note of all of these things, let's go back through the description really quick and see if we can identify either a confounding variable or an extraneous variable. So once again, our question says, a market researcher was asked to evaluate three models of skis, Model A, Model B, and Model C, to determine which was the fastest and thus should be marketed. She hired 30 expert skiers to test the skis. Each skier was fitted with a pair of skis of each model type. To control for the possible effects of some extraneous variables, the boots and other clothing worn by the skiers was held constant. Similarly, to control for order effects, all skiers used the three models in the same sequence. Finally, to avoid fatigue effects on run times, she had all skiers make the first run at 9 a.m., the next at 11 a.m., and the last at 1 p.m. After analyzing the data, she found that run times were significantly faster for A than B than C. She advised the manufacturer to market Model A. Right? So, right away, you guys should notice, right? The researchers aren't just manipulating A, B, and C, they're also simultaneously manipulating the time of day, right? The time of day that the that each model is used. Right? So why does that matter? Well, let's look at this very carefully. I apologize for all the erasing. I write too big. Okay. So I'm gonna do a little diagram for you just to make this more concrete. Okay. Okay. So again, a confounding variable is a variable that is unintentionally manipulated systematically along with the levels of the independent variable, right? So here we have our IV of models, right? Ski models. We have A, B, and C, oops, and C, right? And what we want to observe is the effect of models and only models on run times, right? But we also have something else. We also have something else that is also varying at the same time systematically, right? So we have our intended independent variable, but we also have our confounding variable, which in this case is time of day, right? So the participants always use Model A at 9 a.m. They always use Model B at 11 a.m. And they always use Model C at 1 p.m., right? So why does that matter, right? Well, in essence, if we were to observe an effect, right? So if we were to observe faster run times for Model A, right? So if Model A is faster than Model B and faster than Model C, right? If we were to observe that effect, we now have two possible explanations. right? So if run times are fastest for Model A, it could be due to the fact that Model A is better, right? So one explanation is that Model A is better, okay? And that's what the researchers concluded in this study, okay? But an equally plausible explanation has nothing to do with Model A, right? Because time of day is also systematically being varied, right? So it could be that Model A is better, right? It's a better ski. Or it could be that 9 a.m. is a better time to ski, right? And um, all of you athletes, right? I'm in a wheelchair, so I've never actually tried to ski before. But all of my wonderful students that are athletes, right? If you've ever tried to ski, okay, you know that the snow is most amenable to good skiing, right? When it's tightly packed, right? Tightly packed. You don't want like soft, like slushy snow, right? So optimal skiing time, as it turns out, is 9 a.m., right? So it could be that Model A is the better ski, or simply that this time slot, no matter what kind of ski you use, is going to lead to the fastest run time. Okay? So our limitation or our confounding variable is model of ski, or excuse me, is time of day, right? Okay. So a good question then is, how do we fix it? How do we fix it? So I want you to think to yourself, how can we make this better, right? Well, one really easy solution, right, is just to do a follow-up experiment, right? And in that follow-up experiment, all you have to do is, okay, we're going to get rid of the confounding variable. How are we going to get rid of the confounding variable? What we're going to do is, between participants, okay, we're going to have some participants ski, um, or some participants use Model A at 9 a.m., 11 a.m., and 1 p.m. We're going to have some participants use Model B at 9 a.m., 11 a.m., and 1 p.m. Okay. We're going to have some participants use Model C at 9 a.m., 11 a.m., and 1 p.m. Okay. So we're going to manipulate time, okay, between subjects. Okay. So everybody is still getting A, B, and C, but what time they use each of these skis is going to vary between participants. Okay. When we do that, we eliminate the confounding variable, right? Because everybody is going to ski at one of those times, right? And if we still see that Model A is leading to faster run times, right? We've gotten rid of that confounding variable, right? So now there's only one thing or one explanation that could explain it, which explain this pattern of results, which is that um, that Model A is better. Okay. All right. So thank you so much for hanging in with me for this video. Hopefully this made sense, but if you are confused, or if you want to talk about this with me further, please feel free. Okay. So let me just recap really quick if you're like furiously taking notes, right? So for number one on the homework, okay, your answer should be experimental. because again, we have an independent variable being manipulated, which is model of ski. Our levels of the independent variable are A, B, and C. Our dependent variable is runtime. And if we were doing an operational definition, it would be runtime in minutes or minutes that it takes participants to ski from point X to point Y. Okay. Um, and then our limitations, right, or problems with this experiment is that we have a confounding variable, right, which is one of the problems with experimental designs. And a confounding variable in this case is that in addition to manipulating with the independent variable A, B, and C, okay, so our independent variable is modeled of ski, right? But there's also a confounding variable associated with that. So because model A was always at 9 a.m., model B was always at 11 a.m., and model C was always at 1 p.m., right? We have to kind of take those things apart, right? Because we now have dual explanations for better performance. Is it model A that we consciously manipulated? Or is it time of day, right? Is 9 a.m. just a better time to ski, right? Okay, so those are all the components of problem number one and your homework. If you're struggling, if it doesn't make sense or you're getting confused with all the details, you can certainly reach out to me. A lot of my students, what I recommend is if you're overwhelmed or if you're not understanding something, just pop into my office hours, 1 to 2 p.m. every day, and you can even work on your homework, okay, like on Zoom and just like ask me a question as you're going through it, um, or whatever else you need. Okay, so thank you for watching this unintentionally long video, and have a great day.